All right, ready to rock and roll. So today we're going to talk about slant asymptotes. So vertical asymptotes look like this. Vertical lines. Horizontal asymptotes look like this. Horizontal lines. And they steer our curve. Cannot cut through the vertical asymptote. Those x values are not in the domain. So if there was a vertical asymptote at x equals 1, 1 would not be in the domain of the function. Horizontal asymptote. Say there's a horizontal asymptote at y equals 2. That means the further right you move, as your x values approach positive infinity, your curve is going to bend towards a height of 2 or bend towards a height of 2 like that. Same thing on the left. If you move towards negative infinity, you're bending towards a height of 2. What do you suppose a slant asymptote looks like? It's on a diagonal, okay? And it's only for rational functions. Rational functions are functions that are in the form of a fraction. Slant asymptotes occur when the degree of the numerator is 1 more than the degree of the denominator. So that means the numerator would have a degree of 5, the denominator has a degree of 4. Or the numerator has a degree of 3, the denominator has a degree of 2. Or the numerator has a degree of 2, the denominator has a degree of 1. If it's 2 more or 3 more, there's no slant asymptote. Okay? Now, a function can have a vertical asymptote and a horizontal asymptote. It might have a vertical asymptote and a slant asymptote. You can't have a slant and a horizontal. They can't exist on the same curve. Reason being, if the degree of the numerator is 1 bigger, we always said previously that there was no slant asymptote, or the slant asymptote did not exist. Sorry, no horizontal asymptote. It did not exist. If it's 1 bigger and only 1 bigger, that's the situation where you get a slant asymptote. And to figure out where the slant asymptote is, you do division. I'm going to put a little note here. You ignore the remainder. Someone at the door here, so I'll pause this. Our example says y equals 2x cubed minus 3x squared plus x minus 3 divided by x squared plus 1. So I've got a third degree polynomial divided by a second degree polynomial. And I can see that the degree of the numerator, 3, is 1 bigger than the degree of the denominator. So I know this has a slant asymptote. To find my slant asymptote, I'm going to divide. So think of when we were doing factor theorem. If I divide the polynomial 2x cubed minus 3x squared plus x minus 3 by the polynomial x squared plus 1, I am going to start. So it's 4 terms divided by 2 terms. I'm going to start with the first term, 2x cubed, and I'm going to divide it by x squared. So if you want to do that off to the side, 2x cubed divided by x squared, what does that give me? What's 2 divided by 1? 2, and x cubed divided by x squared, and then is x. That's right. And I would put that on the top. Do you remember what I do from here with the 2x and the x squared plus 1? I multiply them together. 2x times x squared. X cubed. 2x times 1 would be 2x. I'm going to put it back here. And then I'm going to subtract. See why I put the 2x under the 1x? Like terms. I subtract. 2x cubed minus 2x cubed, there's 0x cubed. Negative 3x squared minus 0x squared, that would leave negative 3x squared. 1x minus 2x, that's negative x, or negative 1x. Negative 3 minus 0 would be negative 3. Ignore everything above the line, and then you just start the process over. I have a negative 3x squared. I'm going to divide it by x squared. I have 3 terms dividing by 2 terms, negative 3x squared. If I write that over here, divided by x squared, what's that leave? Negative 3. I'll put that up top. And then I'm going to multiply. Negative 3 times x squared gives me negative 3x squared. Negative 3 times 1 is negative 3, and I will subtract. Notice how I wrote the constant negative 3 under that constant negative 3. Negative 3x squared minus negative 3x squared would be 0x squared. Negative 1x minus 0x would be negative 1x. And negative 3 minus negative 3 would be 0. Now I don't want to do this again. If I divide negative x by x squared, I end up with negative 1 over x. So this becomes my remainder. And I'm just going to ignore it. So the division is done. I ignored the remainder. Where is my slant asymptote? Slant asymptotes, like horizontal asymptotes, have the equation y equals, and they'll always be in the form y equals mx plus b, because if you're dividing a degree 3 by a degree 2, you're left with a degree 1. Or a degree 2 by a degree 1, you'd have degree 1. Degree 5 by degree 4, it's always going to be something x plus something else, or minus something. So my slant asymptote would have the equation y equals 2x minus 3. Okay? You ignore the remainder. That's right. This is your slant asymptote. Because that's what's left on top here. That's what I found using the division. So whatever's left on top, that's your answer. Cool? Now, if I wanted to draw that, okay, so I'll get a graph. I'll drag this picture out. It's a little different. Like if I want to draw a vertical asymptote, like we did in our last question, I knew there was a vertical asymptote at x equals negative 2. All I did was I went 2 units to the left, and I drew a vertical dashed line. I know my curve can't cut through that. There's only one vertical asymptote. I knew I had 2 branches. I had a horizontal asymptote at y equals 1. I went 1 unit up, and I drew a horizontal dashed line. And I knew that as I moved to the extreme right, my curve bent towards a height of 1. And same thing as I moved towards the extreme left. As I approached negative infinity, my y values approached a height of 1. How do I draw a slant asymptote? You got to think back to grade 10 math. So what's the slope of this line? 2. And what's the y-intercept? What's the b value? How do I use that information to graph that line? First thing I would do is I would start by putting the y-intercept at negative 3. I'd go 1, 2, 3 units down. And I'm just going to draw a small little red dot. Because realize this isn't actually my curve. This is going to kind of help steer my curve as I move to the extreme right or extreme left. So I put the y-intercept on. And then I'm going to use my slope. I'm going to rise 1, 2, and run 1. Rise 1, 2, and run 1. Up 1, 2, run 1. Up 2, right 1. Up 2, right 1. Up 2, right 1. I could also go down 2, left 1. Down 2, left 1. Okay? And I am going to join those with a dashed, I'll use the same color, dashed green line that I used or my vertical and horizontal asymptotes. So that's how you would draw. Cool? And what happens, the further right I move, the closer I come to the slant asymptote. Further left I move, same thing. Try one more example. It's just asking you to find the slant asymptote. I'm going to add this to it. And the vertical asymptote. How do you find the vertical asymptote of a function? Anyone remember? Take the denominator and do what with it? That's right, look at it. For the vertical asymptote, I took the denominator, x plus 2, and I set it equal to 0. So in this case, I'm going to take the x minus 1. I'm going to set it equal to 0. This one doesn't factor. Okay? What would my vertical asymptote be? 1. Okay? Now I could test the left of 1, and I could test on the right of 1. I want to see if my y values are going to approach positive infinity or negative infinity. The denominator of this calculation should be fairly easy. What's a number on the left of 1, an x value of 1? 0.9. What would 0.9 minus 1 be? Yeah, so the denominator is going to be a negative. Okay? It's a little more abstract figuring out the numerator. You don't have to figure out exactly what it is. You just want to know if it's positive or negative. But if you plug the 0.9 in there, what's 1 plus 0.9? 1.9. What about 0.9 times 0.9? Well, what's 1 times 1? 1. 0.9 times 0.9 is definitely less than 1, isn't it? So you're going to have 1.9 minus 0.81. What would that give you? What's 1.9 minus 0.81? Positive or negative? It's a positive. Thank you. And what happens when you divide a positive by a negative? It becomes negative. And I'm going to write negative infinity because the truth is, if I chose something closer to 1, like 0.99 or 0.999, this is going to get smaller and smaller and smaller. And the process of getting smaller is my y values are approaching negative infinity. Do the same thing, except we're going to use something on the right of 1. 1.1. What's 1.1 minus 1? 0.1. If I went 1.01, I'd be dividing by 0.01. If I divided by, or went 1.0001, then I'm dividing by 0.0001, which would be the same thing as multiplying by 1,000. Fill a 1.1 in here. 1 plus 1.1 is 2.1. 1.1 times 1.1 is 1.21. So I've got 2.1 minus 1.21. It's a positive. So I know on the right of 1, my y values are getting infinitely large. How do I find the slant asymptote? How do I know it has a slant asymptote and not a horizontal? The denominator is 1 less than the numerator, or the numerator, the degree of the numerator is 1 more than the denominator. That's right. That means I got a slant. And to find that slant asymptote, I am going to divide, and I'm going to write it like this, negative x squared plus x plus 1. Are you okay with that? I just changed the order of the terms. I put the x squared or the negative x squared in front of the positive x in front of the constant 1. It means the same thing. They're just now written in descending powers of x. I will divide the first term by x. Negative x squared divided by x would leave a negative x. Good. That goes on top. Multiply the negative x by x to get negative x squared. Negative x times negative 1 to give positive x. And what do? Subtract. Negative x squared minus negative x squared would be 0x squared. 1x minus 1x would be 0x. 1 minus 0 would be 1. Now there's no point in dividing 1 by x because that's just going to give me plus 1 over x. So what does the 1 represent? The remainder. And I ignore that. Can anyone tell me what the equation of my slant asymptote should be in this case? Y equals negative x. That means it's got a slope of, and it's got a b value or a y-intercept of what? What's after that if there's nothing written there? 0. All right, let's try and draw this and provide a little context to what this curve would look like. First of all, I'll start with my vertical asymptote. Where was it? X equals 1. So where does x equal 1? Here's where x equals 0. Which direction should I move? To the right. Good. And what type of line should I draw? A vertical. And I will identify that x equals 1. What did this information tell me? That on the left of 1, my y values are getting what? Infinitely smaller. So where should I draw that little dot? Here's the left of 1. Should I go way up to the top or way down to the bottom? Down to the bottom. Cool? What's this tell me? On the right, it's getting infinitely bigger, so my y values would be bending upwards. Cool? How do I draw the slant asymptote? Start by placing the y-intercept on. That's right here. And then use your slope, -1, to draw it. How do I rise -1 and run 1? Not to the left. I'm rising -1. I go down 1 and right 1. Down 1, right 1. Down 1, right 1. Down 1, right 1. I guess, Lucas, you could think of it the way you suggested. I could go up 1, left 1, up 1, left 1. And I'm going to join those with a slanted dashed line. Now here's what I know. I know that the further left I move, the closer I come to this dashed line. All right? And the further right I move, as x approaches positive infinity, the closer I get to this dashed line. I would likely have a scenario like so. See if I can draw this half decently. Got a little wobbly there, but that is what my function would look like. That's what the curve y equals 1 plus x minus x squared divided by x minus 1 would look like. Now, we could again get into finding x and y intercepts. We could check for symmetry. We're going to learn how to do the intervals of increase and decrease, which will lead us to finding maximums and minimums. We'll talk about the second derivative and intervals of concavity and inflection points. And in the end, we will be able to provide a detailed sketch. Okay? Your homework, for the most part, today will just ask you to find the slant asymptotes. It'll focus mainly on the division part. But as we move forward, we're going to start to focus more and more on the actual sketch. So you can go to work on the sheet, and I'll stop the video.